right, so 2.1 is about quadratic functions. Does anybody know what a quadratic function is? So quadratics are x squared functions. And what do x squared functions look like? Parabolas. So we're focusing on parabolas in this section. So we kind of talked about them in chapter 1, but we're going to go a little bit deeper about parabolas in 2.1. So the first slide talks about a polynomial function. Poly means many. So it has many terms. Quadratic is a type of polynomial function. So polynomial is just like the broad topic. We have different types of polynomial. You could have a x cubed graph, but quadratics are just the x squared. So that's what we're going to focus on, x squared graphs. In section 1, we talked about the graph of a line, which is y equals mx plus b. So this is what a line function is. So whose slope is m and whose y-intercept is 0, b. In this section, we're going to talk about quadratic functions, which are given in this form. So we have a times x squared plus b times x plus c. So this is the standard form of a quadratic function. So notice here that the coefficient in front of the x squared, that's going to be our a value. The coefficient in front of the x is our b, and then the constant is c. All right, so this just talks about quadratic functions a little bit deeper. The graph of a quadratic function is a special type of U-shaped curve called a parabola. So parabolas occur in many real-life applications, especially those involving reflective properties, such as satellite dishes, because satellite dishes are like U-shaped. My favorite application of a parabola is like when you throw a ball. So if I was a person and I threw a football, it has like this shape. So that's a parabola also. So those are a couple questions from WebAssign that are not really word problems, but like real life applications. So it kind of gives you an idea of how we would apply quadratic functions in real life. So all parabolas are symmetric with respect to a line called the axis of symmetry. So if I had a parabola here, it is symmetrical right down the middle. And that line down the middle is my axis of symmetry. And the point where the axis intersects the parabola, so that would be this point down here, where your axis of symmetry intersects the parabola, that is the vertex. On the next slide, we have basic characteristics of a quadratic. So the left side is when a is greater than 0. So when that leading coefficient is positive, our parabola opens up. It's like a smiley face. When it's positive, it opens up. Our domain of a quadratic function is always all real numbers. The range can vary depending if we have a shift or not. So it starts at whatever our vertex value is, that y in our vertex. And if it opens up, it would go to infinity. If it opens down, it starts at negative infinity. We increase and decrease here. It's an even function. And then our axis of symmetry is always x equals, but depending on if it has a shift, it's not always x equals 0. And when it opens up, our vertex is at the minimum. So we have a minimum value at the vertex. Now an a is less than 0, so our leading coefficient, that coefficient in front of the x squared, when it's negative, our graph opens down. Our domain is still negative infinity to infinity. Our range now starts at negative infinity and goes to wherever our graph stops. But here we have a maximum at the vertex. So when our graph opens down, our vertex is at the maximum. It's now at the highest point of our graph. The vertex is at the lowest point when it opens upward. So that would be the minimum. When it opens down, the vertex is at the maximum. All right, so example 1. We're going to sketch the graph of each function by hand and compare it with the graph of f of x is equal to x squared. So this graph, just our x squared graph, starts at 0, 0. Vertex is at 0, 0. Do you think it opens up or opens down? Down. This one. It opens up because it's positive. So it opens up like that. Now looking at A, do we think this opens up or opens down? Down, because our leading coefficient here is negative, so it opens down. And then we're adding 1 to it. So what type of shift do you think this plus 1 on the outside is going to do? Perfect. It moves our graph up 1. So we just take that same shape that we had of our parabola, move it up 1, but it also opens down. So our graph looks like this. So it opens down, and the plus 1 means that we go up 1. For B, is my graph going to open up or open down here? It opens up. My leading coefficient's positive. I don't have a negative there being multiplied to the x squared. What do you think this plus 2 being added on the inside is going to do? Move it to the left too. And what about minus 3 on the outside? Down 3. So we just take our vertex, we go to the left 2, and down 3. That's our new vertex, and we said that it opens up. So our graph looks like this. So inside the parentheses, we move left or right. So I'll actually do an example down here. If I had x plus 1 squared, I'll say plus 4. This plus 1 means I go in which direction? Left 1. And plus 4 on the outside goes which way? Up 4. And then another example would be if I had x minus, I'll say minus 2 squared minus 3. Minus 2 on the inside goes which way? Right. So right 2, and then the minus 3, down 3. So if you're adding it on the inside, it goes left. If you're subtracting on the inside, you go right. So inside is horizontal. So looking at, we'll find the axis of symmetry for both of these. So looking at the first one, what's my axis of symmetry? Awesome, x equals 0. It's always, always, always x equals for axis of symmetry. And here it's x equals 0 because we go right through 0. Looking at B, what's my axis of symmetry here? Perfect. X equals negative 2. The next slide is the solution to A, and then the slide after that is the solution to B. So So these are just the answers to the last two. All right. Next, we have a different form of our quadratic function. The book calls this one standard form, but it's vertex form. Because the last one was standard form, so this would be vertex form, because you can clearly identify the vertex here. Our vertex is h comma k. It's whatever we're adding or subtracting inside, but we change the sign of the h and whatever we're adding or subtracting outside. So we always change the sign of h. On WebAssign, it'll call this standard form. So when it asks for standard form, it's actually asking for this one. So the reason why it switched, some textbooks do it this way, where this is standard form, and the other one is just, it's not, the other one's not vertex form, but they just have a different word for it. But this is actually vertex form, because you can see the vertex.
You only change the sign of h.
Only change the sign of h. Yes. Right, and then another point here is that our axis of symmetry is that x is equal to h. So whatever our h value is, that is our axis of symmetry. Change the sign. So notice how here it's a minus h, but here it's a positive h. So you just change the sign. So it'll be the same thing as whatever this h is in your vertex. So like the x value in your vertex is the same as the x value in your axis of symmetry. And then again, the a, that leading coefficient outside, if it's positive, it opens upward. So positive opens upward, negative opens downward. So next we have example 2. I'm going to come back to this one. I want to skip ahead 2 slides. So to slide 13. Yeah, slide 13. So to find the vertex, we're going to use our formula negative b over 2a. And then to find the y, we find f of negative b over 2a. So let's start by finding our x and our vertex. What's our a? What are we going to plug into a? 2. This is a. And what's b? 8. And then c is 7, but we don't use that for finding our vertex. But it's good to know. So I'm going to plug in negative 8 over 2 times 2. So this would be negative 8 over 4, which simplifies to what? Negative 2. So my x value in my vertex is negative 2. Now, how do I find the y value? Plug in negative 2 into my x's. So I have 2 times negative 2 squared plus 8 times negative 2 plus 7. So we plug the negative 2 into the x's. And we solve for y. So negative 2 squared would be 4. So I have 4 times 2. 8 times negative 2 would be negative 16. So this would be 8 minus 16 plus 7. 8 minus 16 is negative 8. And negative 8 plus 7 would be negative 1. So my y value is negative 1. So my vertex is negative 2, comma negative 1. What is my axis of symmetry? Just negative 2? What do I need for my axis of symmetry? It's not just a point. What is it? X equals negative 2. Your axis of symmetry is a line, so you need that x equals. I can graph this. I'm going to put my vertex at -2, -1. Does my graph open up or open down? It opens up because A is positive, so that means it opens up. So we open up like this. My axis of symmetry goes right through -2. And then the last thing I'm going to do here is put this equation in vertex form. So it gave it to us in standard form. It doesn't ask us to put it in vertex form, but on WebAssign you'll have to do it, so I just want to practice it with this one. So our vertex form is a x minus h squared plus k. Y equals a times x minus h squared plus k. So what's my a? 2. It's right here. 2. So 2. Then I have x. What's my h? -2. H and k come from the vertex. So this would be minus -2. And what happens when you minus a negative? Becomes plus. So plus 2 squared. And then what's my k? -1. So that would be vertex form. So to find the vertex when it's given in standard form, we use this formula here. So when we're given a quadratic function like this, we use -b over 2a to find our vertex. So this -b over 2a is the formula we want to use. And a comes from the coefficient in front of the x squared, and b comes from the coefficient in front of the x. And then to find the second number in our vertex, the y value, we take x, so we take the -b over 2a and plug that in. So we plug it into x, and we solve for y. This slide talks about the max and minimum values. So the max and min are the y values in our vertex. So whatever the k is. So whether it's a max or min, it is always the k in our vertex. So if our vertex is h comma k, the minimum value will be the k and the maximum value is the k. So it's the y value in our vertex. Y value or k. So given point B is -7, 3 and vertex is 4, -1, write the equation of the parabola in standard form. So vertex, we're asking for this one. So do I have h and k? Yep, h is 4 and k is -1. So I could plug those in. I'll say y equals a times x minus 4 squared minus 1. So I just plugged in my h and k. Do I have anything else? I have x and y here. So this is x and this is y. So I can plug in my x and y. What is not given? A is not given. So that's what I'm trying to find. So I plug in my x and y, h and k, and I'm going to solve for a. So I have, what should I do first? Square the inside parentheses. So it'd be -7 minus 4 would be -11. And -11 squared is what? 121. What could I do next? Add 1 to the other side. So 4 is equal to 121a. And then what's next? Divide by 121. So our a value is 4 over 121. And that's all we need. So I have f of x, or you could say y, is equal to, our a is 4 over 121 times x minus h, so x minus 4 squared minus 1. And this is our vertex form.